Have you seen electromagnets picking up scrap metal? The magnet starts attracting metal only when it is at a certain distance from the heap. Why is the magnetic effect not felt beyond a certain distance? This happens because of the invisible field around the magnet where it displays its properties. Can you quickly recall the basic properties of a magnet? Magnets show polarity. One side of the magnet is north-seeking and the other side is south-seeking. Unlike poles of magnets attract and like poles repel. Magnets attract magnetic material. Magnets have an area within which magnetic effects are felt. This area is known as the magnetic field. Let's perform a simple experiment using a bar magnet and a compass. Fix a sheet of white paper on a drawing board. Place a bar magnet in the center. Sprinkle iron filings uniformly around it. Tapping the board gently makes the iron filings arrange themselves in a pattern. This pattern is the result of the amount of force exerted by the magnet. The more is the force, the more are the iron filings clinging to the magnet. This is true for the areas closer to the magnet. By drawing magnetic field lines, we can see where the magnetic force is the strongest. Patterns show the relative strength of magnetic fields. Thus, we see that the strongest forces are at the poles. As you can see here, the magnetic force is strongest near the poles. Can you explain how you would draw the magnetic field lines with the help of a compass? A tedious way of tracing magnetic field lines is by tracing the pattern formed by the iron filings around the bar magnet. An accurate method of drawing magnetic field lines is by using a compass. A typical compass needle, too, is a magnet. It is suspended on a pivot needle and it comes to rest in a north-south direction of the earth. What will happen if you place a compass near a bar magnet? When you place a compass near a bar magnet, the compass needle deflects. Both being magnets, their like poles repel and unlike poles attract. The angle of deflection depends on which part of the bar magnet you are placing the compass. The magnetic field direction is the direction in which the north pole of the compass points. Alternatively, you can move the compass from the north pole of the bar magnet to the south pole and in the process map the deflection of the compass needle. Keep the south pole of the compass pointing towards the north pole of the magnet. Plot both the points. Plot similar points from the north end of the bar magnet to the south end. Join all the points marked on the paper by a smooth curve. This is the magnetic field line. Did you notice the deflection in the compass needle? It increases as the needle is moved towards the poles. What can you conclude from this observation? Now, let us look at magnetic field lines. They emerge from the North Pole and end at the South Pole. These lines are closed lines. Inside the magnet, the direction of the field lines is from its South Pole to its North Pole. Magnetic field lines are closed curves. The relative strength of the magnetic field is more close to the magnet. The more crowded the field lines are, the stronger is the magnetic force. Will two field lines ever intersect each other? No two field lines will cross each other. If they did, then it would mean that at the point of intersection, the compass needle is pointing towards two directions. This is not possible. The magnetic field lines also show the direction of the magnetic field. How? When mapping the magnetic field, you will come across points where the compass needle does not point in any particular direction. This indicates that there is no net magnetic field at that point. Such a point is called neutral point or the null point.